Section 10.3 has us working with the quadratic formula. Probably one of the most, popular formulas that we learned in Algebra 2, and one that we're going to hopefully demystify and show that it's actually a pretty straightforward process and thing that we use. So our actual quadratic formula is written out right here. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. You're not required to know how to prove the quadratic formula, at the very least for my class, but if you wanted to look that up, that is something that you could go find online if necessary, but it's not something that we are going to be covering in this video here. So we have our process for going through and writing out and using and applying the quadratic formula. My recommendation would be to pause the video here and write these down for yourselves if you need to. Otherwise, we're going to jump into the process and then go into some examples. So the main thing that we need to do at the very beginning is we want to rewrite the original problem into standard form for quadratic equations. Standard form is ax squared plus bx plus c equals 0. So the a, b, and c that are listed up here in this formula all come from the standard form that we have for quadratic equations right down here. Remember that when we are doing this, a, b, and c can be positive numbers, negative numbers, they can be fractions, they could be decimals, or they could be 0 even. So any combination of those for a, b, and c in standard form is perfectly acceptable, but we need it to be in standard form before we can do anything else with the quadratic formula. This sometimes takes 1 or 2 steps to get to there. This could take 3 or 4 steps to get to there, or maybe something starts off in that form. Just depends on the problem. It should also be noted that once we have everything into our standard form, we can also scale the coefficients if we want to. This means we could eliminate fractions, or we could eliminate decimals, or potentially reduce the size of the numbers that we are working with, essentially dividing everything by a greatest common factor, or factoring that thing out, or anything along those lines. So there's plenty of options at our disposal here within this first step of the process, but it is a necessary one to go through and actually go through the rest of it and apply the quadratic formula. So once we've done this, we need to identify the a, b, and c values, including the signs associated in this formula. I think it's worth writing out somewhere nearby as we're going through this process, and we'll show that here as a, b, and c values. And again, make sure you are including the signs within that. There we go, better underline there. Once we have our a, b, and c values, step 3 says to substitute them into the quadratic formula for their respective variables. When you're doing this, you're doing that substitution, parentheses are your best friend. You want to make sure that you are plugging everything in inside of sets of parentheses. You can use calculators to help speed up this process, and you can use parentheses inside of graphing calculators, and that makes these calculations way easier and generally cuts down on a lot of time we would need to go through and actually solve these problems. But make sure you are using those parentheses when you are substituting in. That's a good habit for not just the quadratic formula, but for all problems in general whenever you're doing substitution. Step 4 then says to simplify the quadratic formula for x using PEMDAS and all previously learned radical properties. So once everything is plugged in, I'm going to simplify everything down. And again, simplification requires the order of operations in PEMDAS to get there. After that, we can check our answers if we'd like to plug those back into the original equation that we were given, or we can kind of just say, here's our answer, and we're good to go from there. So with this, let's take a look at these 4 examples here and see how we apply this process. Jumping into our first example, we are starting off with 3y squared minus 5y plus 2 equals 0. As our process states, we need to rewrite the original problem into standard form, which has already been done for us, so we're good to go there. Step 1 is already completed. We can jump to step 2 to identify the a, b, and c values, including their signs, in this problem. I recommend writing out your a, b, and c values somewhere nearby the problem. I'm going to do it off to the side. for this particular problem, but it's your choice on where you want to write that out. So our A value for this problem is going to be 3, our B value is -5, and our C value is 2. Those are coming just from the coefficients right in front of the variables in these terms here. Once we have our A, B, and C value, we are going to substitute those into the actual quadratic formula. If necessary, to make sure you get it memorized, I think it's worthwhile every now and then to write out the full quadratic formula for yourself. Depending on your instructor, maybe you are or aren't allowed a note card on a test or on homework. So if you need to have this memorized, I think it's worth it to write that out for yourself a few times as you're first going through these problems. But all we're doing now is we're plugging in our A, B, and C value into this formula that we have here. And again, whenever you are substituting, make sure you're always substituting inside of a set of parentheses. I'm going to rewrite this -5 in here just to make it a little clearer. There we go. So again, as we're noticing, wherever a B shows up in this problem, I'm replacing that with the parentheses and -5. Wherever an A shows up, I'm replacing that with a parenthesis, and I'm replacing it with a +3. And then wherever a C is showing up, I'm replacing that with a parenthesis and a 2 inside of that. Make sure you start off with doing this line every single time for yourself. A lot of people who mess up the quadratic formula do not correctly write out and substitute all these A, B, and C values into the quadratic formula itself. So from here, now that I have everything plugged in and substituted, I'm now going to simplify this thing down. Doing this example by hand, we're going to get a +5 out front, plus or minus the square root of, this is going to become 25, minus -4 times 3 is -12. -12 times 2 is going to be -24. Got that there. And then we have 6 in the denominator spot. My next line, I'm getting 5 plus or minus the square root of 1 all over 6. And we know the square root of 1 is 1. Move us up here. So I can rewrite this to be y equals 5 plus or minus 1 all divided by 6. Now with this plus or minus showing up in here, I am going to need to split this thing apart into the instance where I am adding that 1 and subtracting that 1. So I'm going to have y equals 5 plus 1 all divided by 6, and y equals 5 minus 1 all divided by 6. Whatever's going to help you keep that organized and split up for yourself, go for it. Use whatever's helpful. And then we're simplifying each of these things individually. For the first one, I'm getting y is equal to 1. For the other one, I'm getting y is equal to 4 over 6. That fraction can be reduced, and I'm getting down to y equals 2 over 3. Remember that we always have to check and make sure that we have fully reduced fractions in our final answer. But otherwise, this is everything that we have for the quadratic formula for number 1. Looking at example 2, we are starting off with a squared minus 2a minus 15 equals 0. So I wanted to throw this one in because a lot of people will think, well, I've been given a as my variable, so how do I determine which a I'm using for my a value in the quadratic formula, and which one is a the variable that we use inside of here? It's a great question, and we're going to do just a little bit of organization in that process for ourselves to make that a bit clearer. But really nothing is going to change, it's just a slightly different variable that we are using for this problem. So I'm still going to identify my, we'll do air quotes, a, b, and c values for this problem. It's already written in standard form, so that's been done for us. So identifying my, we'll do this, a value, my b value, and my c value. So I'm just writing these a, b, and c right below the equation this time compared to off to the side. You can do whichever one is more comfortable for you, whichever one keeps things more organized in your boat. So for a, quote unquote a, I'm going to use 1. It's the invisible number in front there. B is going to be -2, and C is going to be -15. Separate these out with commas here. And now I can plug these into my quadratic formula. The only difference from the original one is now instead of x, we're using a as the variable. Let me make that line a bit better. There we go. So now I'm going to have -b plus or minus the square root of b squared minus 4 times a times c. Extend these out here. And then all of that divided by 2 times a. Now if you want to, you can go through and solve for this radicand all by hand like we did in our previous problem, or you can plug this into your calculator and let that do all of the work for you. The great part about that is if you plug that in, it's going to save you a bunch of time and effort and potential mess-ups on making errors along the way if you're plugging that in correctly. It should be noted that every single thing inside of this radical, that means every single parenthesis, every single exponent, every single positive and negative sign, needs to be entered into your graphing calculator exactly as it's written out here. If we do that, then we are going to get to our answer. We can do the parts outside of the radical fairly easily on our own. But inside we get a radicand of 64. Okay, saves us a little bit of time. I can do the square root of 64. That's going to give me 8. So that means I'm going to have 2 plus or minus 8 all divided by 2. And so now I need to take this problem and I need to split it apart into the instance where I'm adding 8 and the instance where I'm subtracting 8. So write that out for yourself as necessary. And I really think writing each of these two processes out is very, very helpful. I find a lot of people try and do the addition and subtraction all at once, and it doesn't end well. So I'd recommend taking a little bit of extra time to go through and make that clear for yourself. But as we continue on and finish this off, we should be getting one of our a values, our final answers, is going to be a +5, and the other value is going to be -3. So as we can see, just because we have an a as a variable here doesn't mean this quote-unquote a that we found for the quadratic formula has to correspond at all. Just wanted to show this, as some instructors and some people will look at this and go, oh, this is really tricky because I have a up here and you're going to need a in here. No, not really. We just need to make sure we're distinguishing that this a is our variable and this quote-unquote a plugs into our quadratic formula. So just make sure you're keeping track of those as you're going through the problems, and you shouldn't have an issue with it. Looking at example 3, we have been given something that is not originally in our standard form, meaning everything on one side of the equation equaling 0. So I need to do some rewrites to make that happen. To get it into standard form, I'm going to first distribute this x through to everything inside the set of parentheses. That's going to give me x squared plus 2x is equal to a +5. I want to get rid of the 5 on the right-hand side because I want all of my numbers on the left side equaling 0. So I'm going to subtract 5 from both sides of this equation. My result is going to be x squared plus 2x minus 5 is equal to 0. Now that I have this thing written in standard form, I can identify my a, b, and c values and then plug that into the quadratic formula. So identify that my a value is 1, my b value is 2, my c value is -5. And I can plug this thing into my quadratic formula. I highly recommend that if you are going through this, make sure you are taking this one line here to write out everything being substituted in inside of a set of parentheses. I'll finish off that radical here in a second. Okay, so we have everything plugged in now. And at this point in time, we can determine what the discriminant is either by hand or by calculator. I'm going to determine what this discriminant is by a calculator here, off screen really quick. and I'm getting that the discriminant is going to be 24. Now I'm bringing up the word discriminant here to represent this thing inside the set of parentheses. I'm using that only because we're going to start seeing and working with the discriminant later on in the video, so a little bit of a preview of what's to come there. So now I'm getting that I have 24 inside the radical, and I need to work with and simplify that down as best I possibly can. If you need to, reference the Chapter 9 material on how we simplify down radicals. But in the process of doing so, we should be rewriting this into 2 times the square root of 6, and then all of that is being divided by 2 as well. From here, whoops, I need to make sure I have a negative 2 up front. From here, I now need to look to see, can I factor and cancel anything out? The square root of 6 is not a perfect square. It's a really gross, terrible decimal. So I'm just looking to factor and cancel anything out from the numerator and the denominator if possible. Turns out that I can actually factor out a 2 from the numerator. And now that 2 out front here can cancel with the 2 in the denominator spot. So when those cancel, I'm left over with x is equal to -1 plus or minus the square root of 6. At this point in time, you want to check with the problem or answer key or instructor if you're fine to have your answer written in this radical notation, or if you would need to split it up and then give your answer as 2 decimals. If you were asked to do it as decimals, So here we have our final example of using the quadratic formula, and of course we have to talk about if we have fractions showing up. Similar thing would show up if we have decimals, or similar process if we have decimals, but either way, let's take a look at fractions. Everyone's favorite thing to deal with in math, right? For starters, let's get this thing into our standard form. Standard form still works regardless of whether we have fractions or decimals or integers showing up. So I'm going to get 5 over 4x squared minus 3 over 4x minus 1/2 equals 0. So now everything is in standard form. As listed in the note that was attached to step 1 in our process, we can scale the coefficients up or down to eliminate fractions or decimals or anything like that in the problem. Best way to do that is we need to determine what is the lowest common denominator between every single fraction in this problem. And it turns out for this problem, the lowest common denominator is going to be 4. So we are going to use that lowest common denominator, and we are going to multiply every single term in this problem by 4. Oops, let's make a better 3 show up there. And now I'm going to need to cancel out that lowest common denominator of 4 here with every one of these denominators. So what happens is when I do that, thankfully, all the denominators go away, and I'm just left with integer values left over. So I have 5x squared minus 3x minus 2 is equal to 0. Remember that 0 times anything is always going to remain as 0. But now I have this thing written in standard form, and I don't have any fractions left over. So it just became a problem like we did in number 1 or number 2. So I'm still going to identify my a, b, and c values. We're going to need to do that regardless of if we have fractions or decimals or anything like that. And then I'm going to plug that into the quadratic formula. Now from here, I'm just going to simplify the thing that's inside of our radical here, the radicand or discriminant, as we are going to be seeing here shortly. So I'm just going to plug that into my calculator off screen, and I'm getting that my radicand is going to be 49. I'm going to move this up here so I've got some space to write this all in. I'm getting that x is equal to positive 3 plus or minus the square root of 49, all divided by 10. I know the square root of 49 is going to be 7, so this is really 3 plus or minus 7 all divided by 10. And now I need to split this up into the instance where I'm adding 7, the instance where I'm subtracting 7. And I'll work with each of those and simplify them down individually from there. So in this first one, I'm getting 10 over 10, which is the same as saying 1. Then the other one, I'm getting negative 4 over 10, which is the same as saying negative 2 over 5. And there we have our two final answers for this problem. So remember, just because you see fractions showing up in the original problem does not mean that you have to keep them the entire way through the problem. You can still eliminate them. Just remember, we're determining the lowest common denominator between all denominators in the problem and multiplying by that thing to get rid of all those fractions. After that, you got nice easy numbers to work with from there. This brings us to the second part of the quadratic formula, specifically working with the discriminant, as I alluded to earlier in our examples. So the discriminant is the radicand portion of the radical. It is specifically the b squared minus 4ac value. Now the importance of the discriminant is that it is actually going to tell us the number of solutions of a quadratic equation will have. It should be noted, as stated in here, and I would highly recommend that you highlight, circle, underline, whatever you need to with this. The discriminant does not actually tell us what the solutions are. It simply tells us how many of them we are going to have. So it breaks down into three main possibilities. If the discriminant is something greater than 0, then we are going to have two real solutions. That could be even something as small as 0.00001. That still tells me I'm going to have two solutions. It could be as big as 10 billion. That still means I have two solutions. If the discriminant is equal to 0, then that tells me I'm going to have exactly one solution showing up. And if I have a discriminant that is less than 0, then it means I'm going to have no real solutions showing up. This sometimes gets worded instead as no real solutions or two imaginary solutions. So you'd bring in the I value into there. Depends on the instructor, depends on the problem that you are working with. Make sure you're checking if they're asking for real solutions or imaginary/complex solutions, and you're answering that accordingly. So as we have listed down below here, again, we can see this written as imaginary solutions as well. When you are answering this, sometimes we list these out as no real solutions. Sometimes you might instead list it out as DNE for does not exist, for there's no real solutions that show up. Just make sure you're clarifying that with your instructor or the program that you're working with or in the textbook that you're using as you're checking your answers. So let's take a look at some examples with this and see, for these ones, how many solutions we have to each of these quadratic equations. Taking a look at example 1, it should be noted that similar to the quadratic formula, we need to make sure that everything is written in standard form. Everything on one side of the equation equaling 0. We do have that in this first equation, so excellent. We just need to identify the a, b, and c values before we plug that into our discriminant. So a is 9, b is -6, and c is 1. Make sure again, as you are identifying these a, b, and c values, you are still including the sign that shows up in front of each of those coefficients. If we drop the signs, we will be getting incorrect answers. So once we have a, b, and c, we're just substituting that into our formula for the discriminant. And then it's your choice, and if you want to go through and do this by hand, or if you want to use a calculator. I'll do this by hand once, just to show what we're getting. For the future ones, I will go through and show this using, we'll skip a couple steps, and we'll go through and use a calculator for it. So now that I have a discriminant of 0, we would check back to our notes and notice that if my discriminant is 0, then that means I am going to have one solution. it should be stated, again, the discriminant does not actually tell us what the solution is. It simply tells us how many solutions we will eventually get as we work through this problem. So if you're going through these and you're saying and finding, I'm getting one solution, but I don't actually find it, yeah, that's just the nature of what the discriminant does. So there's nothing wrong with that. And once we have this, and we have the number of solutions written down here, we're good to go. For example 2, we are going to follow the same process that we did with example 1. Everything is already in standard form, so we're good there. I'm now going to identify my A, B, and C values. A is 5, B is 1, and C is 4. I'm writing out the discriminant here for myself just one more time. If necessary, I would recommend that you make a habit of writing this out as many times as you need to until you have it committed to memory. Generally tends to work fairly well if we do that. Now I'm going to go ahead and do this calculation that we have here off screen with a calculator. And when I do that, I'm getting a negative 79. So when we look back at the notes that we took earlier on, we notice that if we have a value that is less than 0, meaning a negative number, then we get no real solution. So, if I could write it correctly, so we have no real solution. I'm going to list the alternative that you could write out with this as well. You could instead say 2 non-real solutions. Again, this does depend on the instructor, the software you're using, anything like that. Either way, you should be getting to one of these two answers. Just make sure you're double checking what you are specifically asked to do with this. But again, like we saw with example 1, I do not know what these 2 non-real solutions are. All I know is that I have 2 of them, and this is as far as we can go with the discriminant. Looking at example 3, we're going to go through and do pretty much the exact same thing we did with our first and second example. I'm identifying my A value, which is 3, my B value, which is 7, and my C value, which is negative 9. And I'm plugging those into my equation for the discriminant. So I have everything plugged in here. Remember, again, use those parentheses as you are doing that for each of these A, B, and C values. I'm then going to plug this discriminant into my graphing calculator to find what value I get. And the result that I am getting is 157. We then go back to our notes and determine, well, I had a discriminant that was greater than 0, which tells me that I am going to therefore have 2 solutions to this thing. Again, I do not know what these solutions are, but I do know that I am going to have 2 of them. And that's all the discriminant can tell us as we go through and use this process. Looking at our fourth and final example that we have for working with the discriminant, we're doing the exact same thing that we did with all previous 3 examples so far. I'm again identifying my A value to be 2, my B value to be negative 3, and my C value to be that positive 6. I'm then plugging that into my equation for the discriminant, making sure that we are still using those sets of parentheses. I'm going to plug this whole thing into my graphing calculator to get an answer. After doing so, I'm getting that my answer is going to be negative 39. So from here, I go back and reference my notes again, and I notice that I have a value that is less than 0, which tells me that I'm going to have no real solution. As we saw with the previous example that had this, I believe it was example 2, you could list off, instead of no real solution, 2 non-real solutions or 2 imaginary solutions. Again, just make sure you are double checking with what your instructor wants the final answer to look like in this particular problem. So as a quick recap of everything that we covered with the quadratic formula, we actually wrote out what our quadratic formula is here. We have our process that we are using as we are going through and applying this thing. Make sure that you are including the signs when you are identifying your A, B, and C values, and when you are substituting things into the quadratic formula, make sure you are including the number and the sign inside of a set of parentheses. We had our 4 examples that we went through here. Then we also worked with the discriminant. Make sure that we are noting that it is the radical portion of our quadratic formula. And all the discriminant tells us is the number of solutions in a quadratic equation. It does nothing to actually tell us what they are. It just tells us how many of them there are. We have our main notes with that written in right here. I would recommend having those written down for yourself if necessary. Again, noting sometimes that instead of saying a non-real solution, we can say 2 imaginary or non-real solutions, either one with that. And then we had our 4 examples that we went through here. Scroll down here and give you some practice problems if you would like to give these a try on your own. I'd recommend pausing the video here. So we're going to scroll down here shortly to go to the answers to each of these. And as we are seeing showing up, we have our answers listed here. Hopefully we noticed if you were doing the group 2, number 2 problems that we had a negative discriminant showing up. That means that for the overall quadratic formula, when we applied it, we ended up not getting any real solution to that particular equation. But with that, that is everything for our 10.3 material, working with the quadratic formula and the discriminant.